Let's talk about fundamental set of solutions. So I picked out an example to use to talk about this. Y double prime minus 4y equal to 0. Hyperbolic cosine of 2x and hyperbolic sine of 2x, I claim, is a fundamental set of solutions for this differential equation. Now the first thing I notice is this is second order, and how many functions do I have? I have 2. So second order, 2. So that makes sense. And by the way, I could even break this down and just say e to the x and e to the minus x are my fundamental set of solutions. But these are used in these definitions of these functions, so either way is fine. So what do I need to do? Well, the first thing I need to do to make sure the fundamental set of solutions is that I need to make sure they're linearly independent. How do I do that? I take the Wronskian. So the Wronskian would be hyperbolic cosine of 2x, hyperbolic sine of 2x, and then the derivatives. Again, I'll remind you that the hyperbolics, the big three, are all positive, as opposed to the trig functions where all the co's are negative and the non-co's are all positive. So this would be 2 sinh 2x. This would be 2 hyperbolic cosine 2x. So what do I get here? I get 2 hyperbolic cosine squared 2x minus 2 hyperbolic sine squared 2x. So you can break it down, just if we don't have the identities memorized, which that's fine. So think about it. This is 2 times e to the 2x plus e to the minus 2x all over 2 squared minus e to the 2x minus e to the minus 2x all over 2 squared. So let's write this out. So this would be 2 times, so let's square, I got everything over 4, because 2 squared there, 2 squared there, so that's 4 in the denominator. So this would be e to the 4x plus 2, because e to the 2x times e to the minus 2x is 1, plus e to the minus 4x. Now watch, here's what I get here. I get minus, again, e to the 4x. I've got a minus in there, so this would be a minus 2, but that'd be a plus 2, because a minus is a plus. That's squared, so again that'd be minus squared is positive, but then this minus makes it minus e to the minus 4x. So watch what I get. This guy cancels out, this guy cancels out. So I end up with 2 plus 2 over 4 is 1. So I get 2, which is never 0. So these guys are linearly independent. Misspelled it there. There we go. Linearly independent. So that's part number 1. Part number 2 is to show they're actually solutions. So what do? I plug each one in. So let's choose y equal to hyperbolic cosine of 2x. So the first thing I do is take the first derivative. The second thing I do is take the second derivative. Now let's plug it into this differential equation. So this would be 4 hyperbolic cosine 2x minus 4 times the function y, so that'd be hyperbolic cosine 2x, and look what you get. You get 0. So this is a solution. Now let's choose the same thing for y equal hyperbolic sine of 2x. So y prime would be 2 hyperbolic cosine of 2x. Second derivative would be 4 hyperbolic sine of 2x. Now I'm going to plug it in, so that'd be y double prime is 4 hyperbolic sine 2x minus 4 times y. Well, y is hyperbolic sine 2x, and look what I get. I get 0. So it also is a solution of the differential equation. So they're both solutions. They're linearly independent. It's a second order, so I've got all I need. So this is the fundamental set of solutions to this differential equation.